So this lecture video is on section 6.2, and 6.2 covers more on graphs of sine and cosine functions. Particularly one new concept that it introduces is the phase shift. So similar to the last section that we talked about, we're looking at sine functions where we can plug in different values for A, B, C, and D, and the same thing goes for our cosine functions. So what is the phase shift? It's a horizontal shift in the graph. So here our phase shift is going to be given to us as negative C divided by B, where again B and C are in these spots for our general form of our function here. And the vertical shift is something that we already talked about in the last section, but we didn't have a whole lot of examples of it. The vertical shift is the distance the center of the graph moves up or down. And here the vertical shift is given to us by D, which again are here in those spots for both the sine and the cosine functions that we have above. Now it's asking us to, for each trigonometric function below, state the period, domain, range, amplitude, phase shift, and vertical shift. Well, the first four are really similar to the examples that we did in the previous section. What's really new in this section is the phase shift and the vertical shift, even though we at least verbally talked our way through the vertical shift in the last section. But let's do it. So, in the same order that we had the answers in the previous section, let's talk about our amplitude, the period, the domain, and the range. And now what we're going to add to it is the phase shift and our vertical shift. Alright, so let's do it. The amplitude, like we had before, is simply just going to be the absolute value of our leading coefficient. Here we don't have one, or you can think about it as being the imaginary number or the make-believe number that's out front here as 1 times it. Right? It's not necessarily an imaginary number, but it's just something that we're imagining instead. So here the absolute value of 1 is still equal to 1. The period for both the sine and the cosine function are given to us by 2 pi over the absolute value of b, and b being the value that we're multiplying to this x right here. And again, the value that we're just multiplying to it is just 1, so you can think of this as being 2 pi divided by the absolute value of 1, or simply just equal to 2 pi. Again, the domain for our sine and cosine functions are always from negative infinity to positive infinity. And the range, since I'm writing this in for all these other ones, let me quickly backtrack here. This was the absolute value of A. Now for our range, we're going to have D minus the absolute value of A to D plus the absolute value of A. D being the value that we're either adding or subtracting to the sine or the cosine function. So again, here in this example, those still remain 0. And A being our amplitude, we already determined that our amplitude was equal to 1. So here we can plug in 1 in there, or we're going to have from negative 1 to 1, and those values are included. So again, they get the square brackets. So these are the first 4. These are similar to the ones that we did in section 6.1. But what's new now in section 6.2 is the phase shift. And the phase shift is given to us by negative C over D, negative C over B, which we have up here in our definitions box. Good thing that definitions box was up there. Got it wrong there for a second. Negative C over B. Here, C is the value that we're either adding or subtracting to x. So therefore, here C is going to be given to us as negative pi. So negative pi, but what we want to do is we want to subtract negative pi. So therefore, C is equal to negative pi, but we still have to have this negative sign out here, so it becomes negative pi, right? To be really, really explicit about it right here, this right here, that is C. So here, since it's a negative pi, we're plugging that in for C. But we want to have negative C, so we still have this negative sign out front right here. And B is the value that we're multiplying to our x value. And again, just like we had up here, you can think that that's just a make-believe value of positive 1. So therefore, here we're going to have negative pi. It's just a positive pi. And the absolute value of 1 is just equal to 1. So this is just going to come out to just pi. Our vertical shift is given to us by D. Again, D being the value that we're either adding or subtracting to the entire rest of this function. And here, we're not adding or subtracting anything to it or from it. So therefore, D is just equal to 0. So our vertical shift is equal to 0. Alright, I'm hoping that for these first 4 right here that jogs your memory about what we covered in section 6.1. And the phase shift and the vertical shift are still, like I keep saying, the vertical shift is something that we talked our way through in section 6.1, but the one main new thing here in this section is the phase shift. So now would be a perfect opportunity for you to pause the video and give number 2 a shot by yourself. I'm going to go through these next couple of examples a little bit more quickly, since it's really just repeating the stuff that we covered in the previous section with addition to the phase shift. So we're asked to find the amplitude, the period, the domain, the range, the phase shift, and our vertical shift for this problem. Again, our amplitude is given to us by the absolute value of A being our leading coefficient here, which is just 3. So the absolute value of 3 is simply just equal to 3. Our period is given to us by 2 pi over the absolute value of B. So here, B is what we're multiplying to our x. Here we're not multiplying anything to our x, or just that make-believe value of 1. So the absolute value of 1 goes in our denominator, so again, this just becomes 2 pi. Our domain is always from negative infinity to positive infinity for the sine and for the cosine function. And our range is given to us by D minus the absolute value of A to D plus the absolute value of A. And this always gets the square brackets. Now, finally, we have a value for D. We're adding 5 to the end of this. So here I'm going to plug in 5 for D. And we just need to add the absolute value of A and subtract the absolute value of A. Again, the absolute value of A we were determined because that's the same thing as our amplitude. So we can plug 3 into both of those sections right here. And now clearly 5 minus 3 is equal to 2 and 5 plus 3 is equal to 8. So therefore our range is going to go from 2 to 8 and it gets the square brackets. Our phase shift is given to us by negative C divided by B. I got it right that time. The denominator is B. C being the value that we're adding to or subtracting from x. So here where this right here is C. So it's going to be negative pi over 2, since we're going to plug in pi over 2 in for C. But now we still want to have that negative sign out front. And B being the value that we're multiplying to x, which again here is just equal to 1. So therefore, our phase shift is negative pi divided by 2 divided by 1, or simply just negative pi divided by 2. The vertical shift is given to us by d. D, again, being whatever we're adding or subtracting to this function here at the end of this. So here it's just equal to a positive 5. That then is number 2. Number 3 is very similar to those examples, just more practice of the same. Again, we're asked to find the amplitude, period, domain, the range, the phase shift, and the vertical shift. Again, if you want to pause the video and give this one a chance by yourself, the amplitude is given to us by the absolute value of A being our leading coefficient here, which is 2. The period is given to us by 2 pi over the absolute value of B. B being the value that we're multiplying to our x, here it's the value of 2. So this is just then going to be equal to just pi. The domain is always from negative infinity to positive infinity. And our range is given to us with the square brackets, d minus the absolute value of A to d plus the absolute value of A. D being whatever we're adding to or subtracting from this. Here d is equal to negative 1. We already determined that the absolute value of A is the same thing as our amplitude, which is equal to 2. So I can plug 2 into both those sections. Now if we do this arithmetic, clearly negative 1 minus 2 is equal to negative 3, and negative 1 plus 2 is equal to 1. I think I might have said 3, I meant to say negative 3 there. So from negative 3 to 1. Our phase shift is given to us by what? Negative C divided by B. C being this portion of the function. So therefore we're going to have negative of negative pi over 4. And B being what we're again multiplying to our x. So we have this. Sorry, this is getting a little tight right here. So let me make sure that we can all follow along with this. Negative, negative. This is going to give us pi over 4 divided by 2. And pi over 4 divided by 2. You can think about this as multiplying it to its reciprocal. So this is then just going to become pi over 8. Our vertical shift is given to us by d. D is whatever we're adding to or subtracting from the end over here. So therefore d is just equal to negative 1. Obviously, as we're going through these things, both in section 6.2 and 6.1, I think it should start to become clear to you that these are simply just definitions that you most certainly have to remember for both the homework and for your exams, right? The amplitude is given to us by the absolute value of A. Period is 2 pi divided by the absolute value of B. Domain is negative infinity to positive infinity. The range is from D minus the absolute value of A to D plus the absolute value of A. Phase shift is negative C divided by B, and the vertical shift is D. Those are definitions that you simply just have to know. Hopefully, as we practice it more here, those are going to start sinking in a little bit easier for you. But those are definitely things that you definitely have to remember for the exam and for the homework. Alright, as I keep saying, if you want to pause the video, now would be a good time to pause the video. But I'm going to go through question number 4 and 5 here a little bit more quickly. The amplitude we're asked to find the amplitude, the period, the domain, the range. I'll give myself a little bit more room here for the range because that was the one that was getting a little bit tight. Then the phase shift and our vertical shift. Again, amplitude is given to us by the absolute value of A being whatever we're multiplying out front right here. So this is just going to be the absolute value of 1. The period is given to us by 2 pi over the absolute value of B. Here, 2 pi. B is what we're multiplying to x right here, which is equal to negative 3. So therefore, this is going to turn into 2 pi over 3. The domain is always from negative infinity to positive infinity. And our range is from D minus the absolute value of A to D plus the absolute value of A. D is whatever we're adding to or subtracting from at the end, right here when it's written in this format. Obviously, clearly, if this plus 4 was just at the front here, so you had something like 4 plus the cosine of negative 3x minus pi, right? It's the exact same equivalent statement. So here now, this would still be D. It doesn't have to be at the end of it. Just remember, it's whatever we're adding to or subtracting from it. It's our vertical shift. So here then we have 4 minus our amplitude and 4 plus our amplitude. So here this is going to go from 3 to 5. Again, we get square brackets on this. Here I got it on one line, even though I left myself a little bit space. Oh well. The phase shift is given to us by negative C over B. Negative C, or simply just C, is whatever we're adding to or subtracting from x. So therefore we're going to have a negative pi. B being whatever we multiply to x. Here it's equal to negative 3. So therefore here this is going to end up with pi over negative 3, which is the same thing as negative pi over 3. And our vertical shift, again, is whatever we're adding to or subtracting from this. Here we're adding 4, so therefore D is equal to 4. In number 5, it's asking us for the exact same thing. The amplitude, period, domain, range. I'm still going to give myself a little bit extra room, even though I didn't need it really in the previous one. And our, oh gosh, let's see if I can spell phase correctly. Phase shift. And our vertical shift. The amplitude again is given to us by the absolute value of A. Here A is going to be equal to 2/3. So therefore the absolute value of 2/3 is just equal to 2/3. Our period is always given to us by 2 pi over the absolute value of B. Here B is equal to pi. So therefore our period is just equal to 2. Our domain is always from negative infinity to positive infinity. And our range is given to us by D minus the absolute value of A to D plus the absolute value of A. Again with the square brackets. D is whatever we're adding to or subtracting from, or simply just our vertical shift. Here it's equal to negative 3. And we already said that our amplitude, or the absolute value of A, was equal to 2/3. So therefore I'm going to have negative 3 minus 2/3 and negative 3 plus 2/3. Do the arithmetic on this, we're going to go from negative 11/3 to negative 7/3. Our phase shift is given to us by negative c over b. C, again, being this portion right here. So we're going to have a negative 2 over b, and b being pi. So therefore, this is going to be... See, now I left myself a little bit extra room, and there wasn't enough extra room. Didn't get it right in this video, but that's okay. Here, this is going to end up being 2 divided by pi. Lastly, our vertical shift is given to us by d. D again being whatever we add to or subtract from this. So therefore, d is equal to negative 3. The next problems are practice problems. So as usual, those are left for you. So therefore, this concludes the lecture video on section 6.2.